Today, we're just going to do a final review for COMP725, talk about what might or might not be on the final. A reminder, course evaluations. I've got pretty good turnout for this class. About 79% of you have completed the evaluation. Thank you very much. That's a pretty good number. Often I have something like 7.5%, and that doesn't get you a good sampling. Remember, of course, that you are doing me, not the ever kind Dr. Yuan. Okay. Yes. What are we going to cover today? First of all, some of the slides are from early lectures of Dr. Yuan. So I went back, I have all her slides, and I reviewed those and copied some of them into today's, changing the format a little bit. Some of them are my old slides. And we have several clicker questions. All the clicker questions were submitted by students. Some are nice questions, some are not. Okay, we talk about computer security. It's all about you. Point out to students that when you go out and work as a programmer, you write any program that's going to be used by other people. Remember that if you make a mistake and leave it vulnerable to attack, then you're going to cause problems for the users. On the other hand, you do have the opportunity to write it securely. You now know of all sorts of common vulnerabilities. And if you can avoid those, if you can take the actions required to prevent those attacks, then you can be assured, or at least not assured, you can much less likely that the users will be attacked. Okay. I think I've said this before, but this is a key to many of the problems. Do not execute user input. Taking user input and using it in a way where it is executed, not just displayed, but actually executed, causes all sorts of problems. SQL injection is one of them, cross-site scripting, cross-site request forgery, redirection attacks. I actually didn't talk much about redirection attacks. It was listed in Dr. Yuan's material, but it just seemed so stupid. A redirection attack is where the user enters something and then you change the website to that input that the user gave. So they type www.acme.com, then the server will direct the browser to that website. Well, that seems pretty stupid. I mean, you just can't cure stupid, so I left it out. Okay. From the beginning of the class, Dr. Yuan mentions the core security problem. And one of the big problems is that people can enter anything they want to in a web browser. They may not behave themselves. They can enter data that will cause all sorts of security problems. They can do things that will circumvent some of the security controls. They may not enter the requests in a particular sequence, because they may not go to the website pages in the order that you expected them to. If they know the URL for a web page that is behind the login page, if they go there directly, will the login system stop them? If it doesn't, then your login system is kind of worthless. And of course, remember that people can do all sorts of things for input. It doesn't necessarily have to be a browser. Users can write programs that mimic the actions of a browser, and can mimic the actions of a browser very quickly and send lots of data, or send a request that would be hard to type in. And again, some users just may not behave properly. They can generate all sorts of sneaky input. And they do not necessarily have to submit their input to the browser. They may modify it on the way between your browser and the server. We've used several tools like OWASP, Z, and there was a tool you were using in your projects, which I don't remember the name of it. What was the tool you used to view, it's a proxy to view information between the browser and the server? Anybody remember? Should I put this on this final? Oh, I have a response for the chat. Web Scarab, yes. Web Scarab, yes. For the record, by the way, Web Scarab has been replaced. It is no longer should no longer be used. There's better tools than WebScarab. Yeah, OWASP Z, I think, is the current replacement for that. But WebScarab still does the job for some things. So that allows people to look at things. If you have a hidden HTML form, a hidden field in a form doesn't show in the browser, but it is sent to the server upon submit. You expect it not to be changed, but of course you can use Scarab or Z or something to change it. You can look at the cookies. Cookies do not display in the browser, but that doesn't mean they cannot be changed going here or there. And of course, there are checks that you might make in the browser that can be circumvented by Scarab or Z or some other tool. And here is our first clicker question that comes to you from a student. So we're going to try this one. Okay, hopefully you can see the poll out there now. Okay, we're waiting for a couple other people to respond. Zoom tells me we have 66% participation. Okay, well, the answers are split between, oh, nope, somebody else voted. Okay, people like true because in fact, true is correct. But I might point out true is, oh, wait a second, I think we, sorry, stop sharing that. Okay. Okay, true is correct. Yes, client component, all processing that occurs in the client server cannot be trusted because WebScarab or Z or other tools can change it, or they might not actually be using a browser at all. But this is a true and false question, and you can guess that true and false questions will probably not appear on the final exam. Okay. Okay, this list came from Dr. Yuan in the first or second lecture. Some of the core security problems. And why do we have them? It's interesting to look at this because as we saw in other lectures that I gave, that not all developers are following all the security procedures that they should be following. And of course, some of them don't know it. The big problem is many of them don't know it. Or some of them may know it, but they are pushed to put the software out very quickly. In other words, everybody wants to get it out by some deadline that administrator set. So you're trying to get the software out by a deadline, and getting it out and making it work sometimes looks more important than making it secure. That's probably not a correct analysis. If it's insecure, it can cause much more danger than if it's not out on time. And of course, there's a big difference between producing code that works and producing code that is secure. Also, the last item on the list is true. Many of the technologies in web applications started long ago, and they're being used well beyond what they were originally conceived, and they may not necessarily be secure for what they were originally considered. We mentioned audit logs. It is extremely important that when an attack is recognized or even suggested by activities, that it's logged and perhaps even an administrator is alerted. Sometimes what you find is a website has been attacked over and over again, perhaps millions of times, but nobody noticed because the website didn't log any of these attacks. Somebody kept trying to log in, nothing happened, so they just kept doing it over and over again. And when it finally gets in and somebody starts looking at, well, what happened? You realize, well, yes, millions of attacks occurred and nobody noticed. So it's important to log these things and for people to view the logs. Some actions may want to produce an alert to key people, so they should look at the log on a real-time basis. Some of the things here that Dr. Yuan mentioned, when people change their passwords or when they just logged on. And of course, major financial transactions should be logged. Don't put critical data in the log. In other words, you should never put passwords or credit card numbers or stuff in the log because other people may see the log. But you should mention if this user did something. And of course, as I mentioned, if you recognize an attack, if you have repeated actions that are obviously an attack, if you're getting JavaScript in constant inputs, then that's probably wrong. If people are putting JavaScript into input fields, you go, oh, that shouldn't be there. That's not just an accidental action. That's an attack. Then you probably ought to take some steps. Some systems will just log the user off, just close off that IP address and not let them do anything for a while. And of course, you need to alert administrators. Some action that will tell somebody something's happening. The slower way is to send them an email message or send an announcement to them. In the old days, and still to some extent now, there are operators, people who manage the systems on a day-to-day basis. Somebody who's sitting there doing things in front of a screen, watching the system run. When you have a huge server farm, somebody's got to be there to make sure everything's working, and they can be alerted if a problem is recognized. And there are some of the common things. Okay, here's a list of attack patterns specified by Dr. Yuan, things that an attacker may do to make sure, or actually a pen tester may do to make sure the system is not vulnerable. First, of course, SQL injection is not possible. That's easy to check if you wrote the code. Make sure you've protected yourself against cross-site scripting, and of course, watch out for poor buffer handling. We've talked about all these actions. Make sure that the vulnerabilities have been eliminated or reduced. Make sure that errors are correctly handled. Make sure that errors are checked. I have found code written by graduate students that ignore errors. Many functions return an error code. You call the function to do something, and it may return an error code. A lot of people call the function and never check to see if it returns an error code. I have seen students do try catch blocks, and the catch blocks have nothing in them. So if an error occurs, nothing happens. I've had students submit assignments to me that didn't work at all, but they didn't get any error messages because the try catch block caught the error and just didn't do anything. So in programs, to keep it secure, make sure that you're catching errors. And of course, make sure that data that is private is protected in motion and when it's still, that is when you are transmitting and when it's stored. Mention logs, make sure that they're protected, nobody else can see them, good access controls, and make sure that security mechanisms are set by default to deny. That is, if somebody does something, don't let them. The default is to keep the system secure. That can cause some difficulties now and again because people will bump up against it when they're trying to do something legitimate or sort of legitimate, and they get caught. But it's better to have, I guess that's false negatives than false positives. Okay. Again, you can bypass client-side controls by using WebScarab or WebZ. And a lot of systems will check things on the client side. Now, sometimes it's nice to check things on the client side because then you can keep from sending a message to the server. It's quicker. The user can immediately check, oh, you entered a bad value. Hey, try something better. But of course, you have to also check it on the server side because somebody might change it along the way. Okay, from Dr. Yuan, Basic Process Security Testing. First, let's take a look at what the application is doing. This is going out and finding out how does the application work? What do you have for the application? If it's a white box testing, you'll have the source code and design documentations. If it's black box testing, you won't have that, but you can go out and do a reconnaissance to find what kind of system is it running, what packages are using. Does the website use PHP? Does it use JavaScript? Does it use Java service pages? All sorts of options. Find out what it's doing so you know what kind of attacks might be made. And then prioritize them. What kind of attacks are possible and what is most important? Obviously, you want to look at those that are most important and most likely first. Look through the common attack patterns. The things we've talked about. Try those. Do those impact it? And of course, use the tools that are available. Also, look at logs, try random numbers and inspect the data that you have. Okay. All right, SQL injection. I know many of you are only taught to concatenate user data to make an SQL statement. You should never, ever do that. That's not at all secure. Oh, you can try to cleanse the input, but it's so much easier just not to do that. There are alternatives to doing that. You can use prepared statements. It's much, much more secure. Also, of course, the principle of least privilege, which applies to all sorts of aspects of computer security. Don't give the accounts more privileges than they need. For SQL, don't run your application on the server as root. I mean, a lot of people do it. A lot of systems default. If you're setting up a Raspberry Pi, the default is it runs as root. Don't do that. Root has all sorts of privileges. You don't want an attacker to get root privilege. So if you run the SQL and you run the web server under an account that has only the privileges that it needs, even if the attacker gets hold of it, they'll have limited access to your system. Okay, again, if you have an SQL account running an application, that account should only run that application. Should only have the access to the tables it needs, only have the access type. Now, if it only reads this table, then only give it read access. SQL comes with a variety of restrictions that you can apply on an account. It's quite flexible. And you can say this account can read these tables and then maybe write those tables. So give it only the access it needs. And then there's the file privilege, which allows it to read generic files on the system. Yeah, disable that. That's going to cause a lot of problems. And as I mentioned, there is a way around concatenating strings together. Here's a prepared statement to do something, and you can see it has a star there. The star in the select statement. Okay, and there's a star, and then the question mark. The question mark is key. The question mark is going to be replaced by some value, not concatenated in, but we're going to prepare it, and then we're going to bind the data to that question mark. So whatever data you put in, it doesn't matter if it has SQL injection kind of information, that'll just be used as data. In a prepared SQL statement, you use it only as data. It doesn't ever use the information as part of the SQL command. It keeps it from being executed. So this is much, much safer than concatenating them together. Oh, And we have another question for you to keep you awake. Okay, need a few more people to answer. Okay, anybody else want to guess? Or even better, select the right answer. All right, that's enough. 3, 2, 1, that's a minute. Here are the results. You can see that somebody thought it ends with // No, I mean Java, C, C++ ended with // but not SQL. SQL ends with --. So obviously D is not correct because A is not correct. Now C, what about C? Have you even ever quotes? You'll find with an SQL injection attack, it works much better to have an even number of quotes because typically you may be replacing a quote as you concatenate it together. And then you will not parse correctly if there's an odd number of quotes because now the string doesn't have the usual ending and closing quotes. You'll have a starting quote, but not a closing quote. Usually when now 0 is an even number, you may want to have 0 quotes. If you're doing a numerical value, then 0 quotes may be the correct number. Okay, any questions about the question? All right, then moving on. Cross-site scripting. There are a couple flavors of cross-site scripting. There's persistent and non-persistent. Non-persistent is the, I got a persistent animal bothering me. Excuse me, sorry. Cat attack. Yes, the non-persistent is the most common. Non-persistent ones are you put out there and direct it usually to an individual user and it comes back. So here's an example where somebody puts a non-persistent one where it goes out and basically with cross-site scripting, you're putting JavaScript someplace where it'll become executed so that when that information is later displayed, that the user input will be interpreted by the HTML or by the JavaScript engine and therefore will be executed. Again, don't ever execute user data. Here's an example. I like this one. I got it from Wikipedia. We showed it before, but I'll go over it again. All right. Carol is going to attack Alice, and she knows that Alice likes to use Bob's website, and so she sends Alice an email with this URL, hidden, of course, so it doesn't look like this, but it displays some happy message on the email, and then when they click it, it goes to this website, and you'll notice it's the script is going to load JavaScript from the evilsite.com, and it's going to go query puppy. So Alice clicks on this, it's going to send it out to Bob's website with the query, as if it was like Google or Bing or something like that, and it will send the query. And then expect that the browser will then send the query back to the user. So Alice clicks on this, and then it comes back to the user, and the Alice's browser interprets the script, and then sends the information to Carol that you can acquire from Alice's browser. Okay. Any questions about that? All right. Then there's persistent ones. Persistent ones are probably more devastating but not occurring as often. They're basically stored. That is, somehow you get a system to store your JavaScript and then display it to many users. It's not unlike non-persistent, but it happens a lot when you have a place where users enter data that they'll then display to other users. Chat systems come to mind. It seems a very popular senior project at A&T is develop Aggie Chat. I've seen several people try to develop Aggie Chat. And Aggie Chat is just an invitation Facebook for A&T students. And they almost always fail to check for cross-site scripting. Of course, it's just, ripe for cross-site scripting. Users enter something, and they'll enter something with a cross-site scripting, and it then appears on other users' websites and executes the JavaScript, which does whatever it wants to. Oh, another question. Okay, enough of this. It doesn't matter what the results are, because this kind of question will not appear on the exam. This is a student question. I don't want to pick on the poor student, but I didn't see any value in asking this on an exam, because I don't know the answer. If I want a URL encode something, I go to one of the websites on the system and just have the information URL encoded or URL decoded, or base 64, whatever encoding. There's many systems on the web, websites you can go to. You can copy and paste information into a field, and it'll display it with base 64 encoding or with URL encoding, or undo it so you can see what it is. I don't know how to URL encode something. I just let the system do it for me. I'm pretty sure that A is correct. I know that D, I don't think D is correct. Okay. Talking about cross-site scripting, there's also cross-site request forgery, XSRF. And it's where you convince the system that you're a different user because you've got the cookies from a different user. And the last sentence here says, cross-site scripting exploits the trust that a user has. When they go to a site, this is going to be valid. And cross-site request forgery says that the site believes it's going to be you because you've got the right cookies. Okay, here's how it goes. You log into your favorite social media site or Aggie Chat or whatever it is, and you get cookies from the browser. By the way, you ought to know how to look at the cookies. That's a hint. And then with your browser, and you open another tab in your browser, and you go to a different site. Now, a link causes your browser to send a request to the social media site. And since you're, in other words, you go to your favorite social media site, and then you go to untrustedsite.com. Untrustedsite.com sends back a website that accesses your favorite web social media site in such a way as to get information. And since you are already logged in to that social media site, then it will, you'll have all the cookies, you have all the information, you are logged in, it trusts it's you, and so therefore it will act as if you're already logged in. So the exploiter, the attacker, will be able to do things it would not be able to do if you weren't logged in. Session cookies. Let's talk a little bit about session cookies. Okay, there are session cookies and persistent cookies. Cookies come in two flavors, like chocolate chip or oatmeal. The session cookies are temporary. In other words, the web server generates a session cookie, sends them to your browser, and the browser sends them back. A general cookie, of course. Every cookie, the server generates the cookie, sends it to the browser. in the HTTP header. And then every time the browser sends information back to that server, it sends it the cookie. That way the browser has information. Cookies are used to establish state, so the so the server knows what you're doing, where you've been, whether you're logged in or not. Okay, so session cookies are created when you log in, and then they're deleted when the browser closes or when you log off the site. Session cookies do not have expiration dates. And typically they're a little bit safer because you don't save them. If they're saved, then somewhere somebody could change them. Persistent cookies, on the other hand, are stored in the file system on the client system, and they have an expiration date. The expiration date come in a couple of forms. You can give it a date. It says this cookie is good until this particular date, like December 25th, 2021, or you can say it's good for 3 weeks or whatever you want. Sometimes they're called tracking cookies because they can be sent to advertisers. Sometimes cookies go to another website when you are logged into one system and you go to a place to get further information, particularly advertising. The cookies are sent by your browser to the advertising site, and it goes, oh, I know who you are, and I know what I want to show to you. So they're maintained. So again, session IDs provide state, and to be safe, you should always include a timestamp and encrypt them. Interesting. Just a few days ago, I got an email from Wikipedia, and it really was from Wikipedia, I believe. I think it was. I hope it was. And it says they're going to put on a program to ask for donations in the near future. And I'm a regular donor to Wikipedia because I use it for my classes and other things. I want to find something out, I go out to Wikipedia and ask it. It's really neat. You know, Wikipedia has no advertising. They rely on donations. And so as a donor, I said, well, if you don't want to see the please donate banners that show up at the top, go to this particular website. And that website will put a cookie in your browser. And then when you go to Wikipedia, the server will check that cookie and go, oh, this is a donor. Do not show them the advertising banners because they've already donated. So it'd be worthwhile to know how that's done. Okay, again, session cookies, need to create strong session cookies, things that cannot be predicted, things that cannot be calculated. Therefore, there should be an extremely large set of possible values. That means make them kind of long so they're hard to get. Random is good, like a pseudo-random, because true randomness is hard to do on a computer, but make them random. Just picking a random number using a secure random number generator, and then that will create a random number that you can send the cookie, and you know when you get it back, it's probably that one. If it's large enough, nobody's going to be able to guess that. Sometimes you want to put timestamps and IP addresses and port numbers and other information in the cookie, in the session token. If you do so, it's important that the cookie be encrypted. In fact, you should almost always encrypt the cookies, unless, of course, it's just a random number, in which case there's nothing there to encrypt. There's no inherent value in the cookie. But if there is, you should encrypt it. Now, it's very easy to encrypt it because the browser does not have to decrypt it. It's just a bunch of bits that you send to the browser. The browser sends them back. So you can use probably AES encryption, since the server is the only one that's encrypting and decrypting it. So it's quick and easy. So you encrypt the value, send it to the browser. The browser doesn't have to decrypt it, doesn't know what's inside, and then just sends the bits back. And the server can decrypt it and say, oh, yep, this looks correct. Clickjacking. Everybody should know about clickjacking. We've done our clickjacking attacks. Clickjacking works by embedding a trusted web page in an iframe, in a web page generated by an attacker. The attacker also provides invisible items in the web page that overlay important information in the trusted web page. And so when you think you're clicking on a value in the trusted web page, in fact, you're clicking on the attacker's or web page, and you go to the attacker. Now, the attacker could do all sorts of things at this point. A cross-site request forgery seems very likely, or the attacker can make a page that looks like the trusted web page. And now that you're at the attacker's site, thinking that you're on the trusted site, the attacker can do all sorts of things. Oh, here's another question. All right, let's pop this one up in the polls. And all right, we've had 4 responses and 4 different answers so far. Somebody else has to break the tie. Okay, well, long enough. Yes, it was a tie. So let me show you. Did Dr. Yuan cover simple network management protocol in the class?
No.
Okay, I didn't think so. I didn't see anything in her. I've covered it in a networking class before, but it's certainly not, well, okay. Simple network management protocol allows you to access entities within your network, entities that might otherwise be transparent, routers and hubs and firewalls. Simple network management protocol is a means of connecting to them, which you can use obviously for management. If somebody's running the network, they might want to know, is this router working? Is the router getting overloaded? SNMP is built for that. You can send an SNMP message to that device and say, what's your status? How busy have you been? And that's very useful for managing the network. Particularly if you get a large network, it's really critical to do this. And if somebody can hack into that, then that could be a problem. You can disable a router or a web, but well, there are, of course, protections against that. Okay, but since it wasn't covered in this class, it will not be on the exam. All right, but what will be on the exam? Well, these are very likely questions. SQL injection. Words given, I might show you the SQL and say, well, what can you type in the user's name or password or something that will produce a certain outcome? And then, let's do a cross-site scripting attack or a cross-site request forgery. Here's a particular situation. What input might do that? And then for all these attacks, well, tell me how to protect against it. What can we do to keep that attack from being successful? And again, we talked about cookies. You know how to get to cookie information. All right. The final exam is 1 week from today. It is 3 to 5 o'clock on Blackboard. It will close at 5 o'clock. I recommend that you do it on a laptop or desktop and not on a phone or tablet. Hopefully everybody has some sort of device to do this with. If you don't, let me know. It just works better on a laptop or desktop than on a phone. Yeah, it's one of those things where I'm going to tell Blackboard, make this visible at 3, make it go away at 5. You have a time, 2-hour time limit to do it. Hopefully be able to get it done in 2 hours. I'll be standing by to during that time period, but I won't be actively doing anything. If you have problems, you can email me, you can call me or text me, and I'll see what I can do to rectify any problems. But that's what we're doing. And again, remember, course evaluations are closing Sunday, so this is your last chance. You can't eval me after the final. You just got to do it before the final exam. Do it for all the classes. It's important. This is your chance to voice your opinion. And I'm proud to say we got a pretty good response rate. We have a statistically significant response. So that's great. Okay, anybody have any further questions about the exam? Thoughts, fears?
Are there any questions that will require just saying, yes, I will do this kind of attack, and then in that time frame, we need to send some kind of attack to your email or something?
I'm going to try to keep it within Blackboard.
Yeah, that will be good, because like for like crafting that kind of attack, that might take more time. That's why I was just wanted to make sure.
Yeah, I'm going to try to keep it in Blackboard. Well, I would really like to do other things. Keeping it in Blackboard reduces the potential for system problems.
Right.
You know, things may not work. My website may not be accessible. You know, who knows? You know, I've been in the business long enough to know that things don't always work well with computers. Things may not work properly. So we're going to keep it in Blackboard. On the other hand, yes, if it says enter an SQL injection, you might have to type the text to do the injection. It could be multiple choice, but I'm not a big fan of multiple guess. I'd rather have you enter some information. Now, that makes it more difficult for me to grade it. So every now and again, I chicken out and have multiple choice. I'm probably not going to have a true and false question. Occasionally, I might warn you, I have had true and false questions followed by why. I might do that.
Yeah, that's short answer, right? It's not
Yes,
just true and
right.
false. It's
Right. It's not just really true and false. Usually, like if it's a 10-point question, you get 1 point for saying true and false, and then 9 points for giving a good explanation. And every now and again, somebody gives the wrong answer, but gives a pretty good explanation for why. And they can get a lot of points in that question. Probably not all the points, but a good explanation based on fact and knowledge counts.
All right.
Okay. Anybody have any further questions about the exam?